let's jump into module 4, which is regression. This is going to be, I think, helpful because it will cover and review some of the data manipulations and the downloading that we've done in the first 3 modules in this course, and then it will wrap it up and do some preliminary and very easy, I think, to understand analysis. So let's walk through that slowly and get going. Now, the notes can be, of course, found in the GitHub under Model 4 Regression. And you don't have to actually create a new RStudio session every single time. What you can actually do is just kind of clear out this, and if you want, clear out the other variables that you're working on from our code from before in Module 3. And you can actually just save the code, and then that code will be there, and then we can get rid of all the variables we were using, and then we can actually just open up a new R script. And the reason that we would want to do this is every time you open a new RStudio Cloud, you actually have to install those packages that we've been installing. The good thing is, if you don't open a new RStudio session and you just kind of work off your existing ones, and you just want to write in a new box of code, you don't have to install those libraries again. So, for example, the dplyr library will already be there for us. Well, let's say that it was already uploaded, but the ones that we had installed from before will already be there, so you won't have that problem. Okay, so let's get to it. So let's actually install these packages right here. I'm just going to do it all at once. And I am, of course, going to use comments. And after those packages have been installed, then we will move to install the data. So we are going to use that WDI package that accesses the World Bank's data. We're going to use that again today. And let's just copy this, just so we can have some clean notes. And then let's just copy this code in. So this code is pretty long. We don't need all of this information. What we need is, we want to get for all countries, we want to get for 2 indicators, GDP and age dependency. And let's just get rid of this because it's actually not important, and we want it to start in 1980 and end in 2020. So now that that package has finished installing, let's just run this WDI function that we've gotten from the WDI library. So we're going to get all the countries in the World Bank database. We're going to get GDP and age dependency as our variables, and it's going to start in 1980 and end in 2020. So we run that, and voila, we have this huge data set now in R with all of that data. It's for the Arab world, different regions, different countries. So it's definitely a very robust and nice data set to download. And now we can actually do some manipulation of that data as we were doing in the previous module. So first, I want to actually kind of filter that data. What I want to do is, you can see here again, when I just showed you, there's, various years in there. I just want 2020. So I am going to type in the name of that data set, followed by the pipe operator, and use the filter function to only grab the year 2020. And remember, this has to be equals to equals in order for it to work. You can also do less than, greater than, so on and so forth. But in order to make that manipulation save, we need to set it equal to its original name. And so when we do that, what you'll notice is now that's gone down to 266 observations or rows. Okay, so it worked. Now I want to rename the columns. Now this one is a little bit not as intuitive as, say, maybe other functions, but you just type in the rename function and you type in first the column's new name, then you set that equal to the column's old name, and if you want to do more than one column, you just add a comma and you can add that there. So if we do this, well, let's add a head function just to show the first couple. And what you'll notice is that the names have now been changed, but if you go in and look, the names are not changed, and that is because, again, we forgot to set it equal. Make sure you get rid of that head function, or else it'll only save the first two rows. And now we have renamed the columns. We can confirm that by using the names function, and then it should show us that the names have been changed. Let's drop some columns. So we set WDF or DFWDI. We just want to select the country GDP and age dependency ratio. So we run this, and now you'll see instead of 5 columns, we have 3. And we just want to get one more data set before starting our analysis, and that is the New York Times data set on excess deaths during COVID. And as I was showing before, we are going to, in the first session, we downloaded a CSV file directly from GitHub, and that's what we're going to do here right now. So we're going to run that URL, and then we're going to stick that inside the read.csv function. And when we run this line of code, you'll see that now we have this new data set. But as before, we want to do some filtering. So before we can filter the date, though, I wanted to actually manipulate the column. So I have this end date column, and it is unfortunately not a date object in R. This is a bit of a more advanced concept, but essentially what I'm doing is I'm taking that column, I'm putting it inside the as.date function, which will convert some data to a date. And so what you'll see is that it looks like it's been converted, but in order to overwrite our column, exactly like a data frame, we need to set that equal to the existing column name, and then it should overwrite it. And now we should be able to filter out all the dates not equal to this. So we're just going to grab all the dates that are equal to this. So it looks like it worked. And if we set it equal to the name, we will hopefully see this observation go down to 17. So that it looks like there's only 17 countries in this data set. And as before, we also want to just select 3 columns. Right now we have 12 columns, and we're going to run that. We want to select country, expected deaths, and excess deaths. Now you'll see that we only have 3 columns. And now we want to create a new column, and we are going to use the mutate function as we were using before in module 3. This creates a new column altogether. And so I want to write mutate, and then the first thing I write is the name of that new column, the new column name. You can name that anything. I'm just naming it excess deaths as a percentage, and the reason I'm creating this is because excess deaths is going to obviously matter how big the country is, but I thought maybe taking a percentage should be a better barometer of whether that country had a ton of excess deaths or whether they are just a really big country. So I'm just setting that equal to the excess deaths column and the expected deaths column. So these are, again, just column names. And if I run this, then you'll see that that new column name has been created, but it doesn't look like it showed up there, and that's because we did not set it equal. So now that those 2 data sets have been created, it's really nice because, oops, I actually by mistake created a new data set. But you'll notice that both of these data sets that I was working with earlier have a country column, so it's really easy to merge these data sets together. So all we have to do is merge them. And so that's just with the merge function, and then followed by the name of that data set, the first data set, the second data set, and then you want to tell that merge function what country to merge it by. So it looks like it worked, but let's save it as df merge, and let's check that data out. And what you'll notice is that we have expected deaths, all that data, but we also had the GDP data and the age dependency ratio, and conveniently, whoops, that's not good. But conveniently, what you'll see is that there's actually only one column, and that column is the country column, which has been kind of reduced from 2 to 1. So it's nice because that merge function just right for us, it gets rid of the overlapping columns. So let's just save this just in case that happens again. So now we have that R script there, but now we want to move on to regression. Now regression kind of sounds fancy, but it really isn't. All it is just finding some type of linear relationship or finding basically a straight line between a graph. I mean, that's the easiest way I can describe it. So for example, I want to compare GDP and excess death percentages, and I'm showing that graph down here in the notes. The regression line will find you the intercept, and it will find you the slope of the best fit line between this data. So the best fit line, if you were to draw a line that included basically the same amount of data on the right side and left side, or the top and bottom, that is regression. Sorry, that's an incredibly crude way to think of it. There's probably a more scientific way to describe it using mathematics, but that's just how I think about it. So I'm going to come back to this plot after we run our regression. The regression is going to be GDP and excess deaths, so that's why I'm plotting it. It's always a good idea to plot before you do regression. And the way you do regression in R is actually really pretty straightforward. You use the LM function, and you put in the Y variable as the first on the left side, and you put it to the left side of this little squiggly line. I don't exactly know what this is called, but it's next to the 1 on my keyboard on the Mac. The X, or explanatory, or regressor, or whatever it is that you want to call it, will be on the right side. So this is what is trying to explain excess death percentage. So you would want to, possibly include regressors that you think could help explain this excess deaths. I mean, GDP, my guess is that the higher it is, the less deaths, excess deaths there will be. And then inside the LM function, you're going to have to provide it the name of that data set that you are reading the data in from. So these GDP and excess deaths are actually in this DF merge data set, of course, that we just created above. And when we run this line of code, we get our result. So like I said, we get the intercept and the slope. That intercept at 0.4 will start somewhere around there. And it's really, really not a steep line. So that's like 0.000 or something. It will be kind of like that. So the best fit line will be like that there. And I can show you, actually, because I do create that, that's what it looks like. And that is basically regression. So if I were to give you some country with GDP, let's say it was 70,000 a year, you would expect under that model that excess deaths would be somewhere around 0.2. If we give you a country with 20,000 GDP, we would expect that excess deaths would be right there. So all of our predictions will be somewhere on that line, and the predictions will differ based on the slope of that line and the country's GDP. And obviously, multiple regression gets a little bit more complicated, but that's the general idea. So we often want to kind of manipulate and save that regression output. So oftentimes we'll set it equal to an object that's called reg, and you'll notice that that has created something right there. And then if you use the summary function over that, you will be able to see a lot more information. So the coefficient, standard deviation, t-values, p-values, etc. you can now see using that summary function. We can grab a number of different pieces of information from that reg list that we had created. So we can grab the residuals, We can grab the fitted values. We can grab the coefficients. If this isn't making sense to you, no worries. You'll probably learn about it at some point in your 610 or 611 class, or possibly somewhere else within the department or out of the department. I'm not going to spend too much time on that because I need to kind of to move along. But if we were wanting to plot what I kind of just showed you here, this is how you would do it. So I would take that plot that I had before. It's the same exact plot. And inside of in the next line, I would take that regression, so that LM regression. And we can just call it reg because it's already been saved. And then I put it in this AB line function. That's just a line. It will draw a line. And I want that line to be red. And now you'll see that it has created it. And the reg, if I were to put this in there, it's the equivalent because that is what I saved up there as reg. And you can see generally what that best fit line looks like. Oftentimes you're also going to want to plot the residuals. I'm not going to get into this too much again right now. It will probably be covered in your econometrics class or later on in your education at the School of Public Policy. Essentially, it's just a way to check whether your regression is behaving properly, whether the results you can trust. If there's something funky going on with the residuals, it might mean that your results aren't very robust. So a lot of times we run, though, more than one regression, and so that's what I want to show briefly in 1.4. You can simply add regressors or explanatory variables by the plus sign. So I'm just adding age dependency ratio in addition to GDP. So when I run these lines of code, you'll see that now I have an intercept, I have GDP, and I have another explanatory variable. Now, again, this in 1.5 is a little bit tricky if you've never covered it, so please skip over this or even end this video a little early if you're not interested in learning this. But this is a robust standard error regression, and it's extremely easy. You just use the MAST package and library, so make sure that's installed. And instead of LM, all you do is add an R, and it will be the robust standard error regression. And the only difference between this and this is that the coefficients will remain the same, but the t-values will be slightly different. So you can confirm that for yourself. But the t-value 2.6 in that one looks like it's the same. But yeah, if you do run that and it works, then it should be different. So now moving on to other kind of diagnostics that someone requested to see because they're covering it in their class. I'm just going to cover 3 really quickly, and it's incredibly easy to do these diagnostics. So let's just clear out everything and run that simple regression that we ran from earlier and save it as the reg object. When we want to do a test for heteroscedasticity in 2.1, all we do is use this package. It's called LM test. And it's incredibly easy to use. All we do is write the name of the test, and that test is a function, and we input that regression, and we run it, and it looks like it hasn't been installed, so that's going to take a minute to install. But after it's done, all you have to do is run that. And then the DW serial correlation and functional misspecification tests are, as you can see, incredibly close. So instead of BP, it's just DW test. And then again, we just pass in that regression, and reset test is the same way. It's reset instead of DW or BP, and then we pass in the regression. And then as you can see here, I got an output for that BP test. And if it is above 0.1, generally we can't reject, and that would tell us that there is not evidence of heteroscedasticity, if I'm remembering this right. You can kind of ignore this note here. It's a bit more advanced, and we can cover it perhaps in other videos or in the future. essentially you can grab different parts of this BP result as we were grabbing from the regression result earlier. So regression is a list, BP is also a list. So that list contains this information called the p-value, and so that's kind of nice to have if we wanted to kind of do some manipulations with it, but we're not going to do that right now. We're just going to finish this up. So we're going to do the DW test next. Again, you can save that as DW, and you'll notice that it's, again, yet another list, and there is ways to probably access the p-value, right? Exactly. For the DW test, generally speaking, we have autocorrelation if it's below 0.1 and it doesn't look to be, but this is a low DW number, and that generally could mean that you have some serial correlation. Again, if you want to know more, please use Google to look that up. And sorry again if this is getting in the weeds, but the final thing that I wanted to show you is the reset test. And that again has the same kind of concept. It shows you a p-value, and if it's below 0.1, that is generally in the rejection territory. So today I wanted to show you how we could bring a lot of that information that we learned in the first 3 modules together. So how to download the data, how to manipulate it, and then finally how to kind of create a basic statistical analysis.